All right, hello sixth graders. We're going to look at our first section of work and welcome, and hopefully you will not have any problem understanding each of the lessons. The first thing that I want to do is for all of you to get your packet information, and let's look through a few things together with it first. And then I will look at each lesson and work a few of the example problems. Hopefully this will help you to be able to work the problems on your own. Obviously, class is a little different now. What you are going to be required to do is to complete each lesson that is assigned. And of course, you'll do that on your own there at home, making sure that you show your work. So if you have to do your work on a separate sheet of paper, just make sure you turn it in when the turn-in time comes around. Now, we're also going to do something else different. For you to turn in your work, you're now going to start tearing out your pages from the book, because I don't want you to turn in the whole book. You're just going to turn in each lesson as you complete it and as they are due. You may tear out the lessons ahead of time before you start working on them, if that's easier, instead of working them in the book. So make sure you do not lose any of the pages, any of your lessons. Now, another thing that's going to go along with this distance learning is I'm not going to be giving you any quizzes or tests. So I know you're going to be really excited about that. Not going to have to take a test. So therefore, your lessons that I'm assigning, as you turn them in, I'm going to be grading each one. So you need to make sure that you complete every problem, because if you leave it blank, it will be counted wrong. And then you need to be sure also that you're taking your time and that you're trying to get all of the problems correct. And as I reminded us in this in your note that gave the assignments, you do not need to use a calculator. You are not to do that. But I will allow, if your parents would like to check your lesson when you're finished, I will allow that. And they can check it in any way they want to and let you know which ones are wrong. And then I will allow you to go back and correct them before you turn it in to me. That'll help everybody to hopefully learn the material and then get more correct so that your grade will be a good grade, okay? So if you have further questions at any time, as it states here, you can send a message in the My Schoolworks right to me, and it's fine for you to do that. Just ask your parents to help you to log in, or they can log in for you. And then it's real easy to use the message system. Click on message, click on compose a message, and then in the blank, start typing my name. And I should come up, choose that, and then you can write your message and send it to me, and then I'll be able to reply to you. All right, so these following lessons that are listed on this sheet are due by Wednesday, April the 15th. And I list for you each lesson to do. And we're going to go through each lesson here real quick today. And the good thing about this video is you can watch it again. So if you need to go back and see me work the problems for a particular lesson, you can go back and find that section. And you can watch it over again, because I'm going to go through each lesson today. Now, so get out your books. Hopefully you have your books nearby. If not, pause it, go get your book, come back, make sure you have a pencil. And then we're going to look here at page 235. This is lesson 130. This is where we should be picking up with what we were doing last time we were together. You have been dealing with angles, measuring angles, remember, with your protractor. So hopefully you have a protractor. You're definitely going to need it for this lesson. Today, with this lesson, you will be constructing angles. And the steps are listed there for you. I'm not going to read all of those back to you. You can read them. But I will draw a few angles for you. We've already done this, but I'll show it to you again. All right? So the first thing we're going to do is just take the straight edge of the protractor and we're going to draw a line, a ray. Okay? So as I take the straight edge, and it doesn't matter the length, okay? Then I'm going to pull my protractor away, and I see that I just have a straight line. We're going to make the vertex an endpoint here. And now I'm going to take my protractor, and we'll go ahead and do the one in the example problem. It says 110 degrees. So I'm going to take my protractor, and I'm going to put my center point right on that vertex. And then I'm going to line up my protractor along that straight edge. Now remember, there's going to be two sets of numbers at the end of your protractor, 0 and 180. Now obviously we want to start with 0. And we're going to follow 0 around, and it's going to go in 10-degree increments. We're going to follow it around all the way to where it says 110. We're going to make a little mark at 110. Now I'm going to pull my protractor away, and I'm going to use the straight edge of my protractor, and I'm going to line up the mark that I made with the vertex. And I'm going to draw that straight line. And there I have constructed a 110-degree angle. Now, in this lesson, they don't require you to label them, but remember, we can always label every point of our angle so that we can designate the name of it. So that's what you're going to be doing on page 235 there. Constructing some angles on your own. And if you notice on number 1, they already have the radius, that first line drawn for you. So all you're going to do is take your protractor there, set it at the vertex, line it up on the ray that is given, mark the degrees, and draw your other line. Now starting with number 2, you are going to be doing the whole thing just like I did on the board here. You're going to have to draw your own first starting point. You're going to measure it, mark it, line up your straight edge, draw that line, and then please label it with the proper degrees. Number 3, you are going to be measuring those angles. Those angles are already drawn for you, and you're also going to be telling, are they an acute angle and an obtuse angle? If you don't remember that, look back a previous few lessons, and that'll give you the definition of those, but you should know that already. Then there on page 236 is some review problems for you to do to keep in practice. All right, then the next lesson. So we're ready already to move ahead to lesson 131. You're going to complete all of it, and it is a review. So again, you may have to look back for some of these formulas. I know you probably haven't been, hopefully you did the lessons you were supposed to do there before spring break. But now you're going to get back in the groove here, and if you need to look back, that is perfectly fine. But you need to know those formulas and all of this different information. Look back. There are example problems for everything because all of this lesson is review. Okay? So, moving ahead, and if you're looking at your list, you see the next lesson listed is 134. And that's for 2 reasons. First of all, there's a test in there that we're not going to do and we skip, so that changes our lesson numbers. And then the second reason, and I made a note of it for you, we are going to skip lesson 133. Okay, 133, and it is something you will do next year in 7th grade. Not that it's not important, but we will cover it in the future using a compass and bisecting an angle. So you do not have to do anything on lesson 133. You skip the entire lesson. Now, when you hit problems, you know how it goes. There's going to be review problems coming up in future lessons. They're going to ask you to bisect an angle with a compass. When you come to those problems, you may skip them in the future as well because we did not teach that. We did not go over that. Okay? So go ahead, moving right along then. We will look at lesson 134. Lesson 134, page 241. A very simple lesson here. You won't have any trouble with it at all. If you look in the top box, they give you a definition of a triangle. All right. Again, we've talked about this already, but here it gives it to you again. A triangle is a three-sided polygon. All triangles have three interior angles. Okay? And you see in the example, they have marked those angles, angle A, B, and C. All of those angles are measurable. You can take a protractor and you could measure each one. Now, something important that we need to know, and it tells you there in that definition, that when you measure all three of those angles and you add them together, it will equal to 180 degrees, always. So that's a very important piece of information for you to remember and memorize. Now, in the rest of this lesson, the other thing it is stressing is three special triangles. Three special triangles, and there they are for you. An equilateral triangle has three congruent sides, therefore also three congruent angles. All right? Remember what congruent means. Exactly the same. So that's an equilateral triangle. So make sure you spell that too. The second special triangle is an isosceles. An isosceles triangle have two congruent sides, okay? So two of the sides, and just as the triangle as it is drawn for us there, two of the sides are the same length, but the base is a little bit longer, if you can tell. So that's an isosceles triangle. And then the final special triangle, very important. You're going to use this for the rest of your math and for geometry for many years to come. That is called a right triangle. A right triangle is special because it has a 90-degree angle in it. All right? So if we wanted to draw 90, you will see that it is perpendicular. It is straight up and down. So I draw a straight edge here, and if I go around to 90, okay, you notice a 90-degree angle, perfectly straight here. Perfectly straight, and it's always designated with this little square. We'll put a square there in the angle point, and that shows that it is a right triangle having 90 degrees. All right. So this lesson again is simple. You will just answer the questions about the information above, and then you'll label some of those special triangles, and then they want you to measure some triangles, and then you have your review page. Well, look at number 4 actually at the top of 242. There, remember, if every triangle equals 180 degrees, and they give you two of the angles, what we need to do is add those together, subtract them from 180, and that will give us the third angle. So you have two angles, you would add those two angles together, subtract that from 180 degrees. That will give you the third angle measurement. Okay? Now, number 5 is bisecting with a compass, so you can skip that, but you need to work everything else there. All right. We're ready now to move on to the next lesson. And as usual, you know how it's been all school year. You'll get a couple of lessons with some new information, and then they like to review. And so, therefore, we have another review lesson there on page 243. So lesson 135 you are going to complete, and it is all review again. So go ahead and skip with me now to lesson 136. Lesson 136. This is something that has a little bit added to it, but you should already be familiar with this. It's called order of operations. This moves away from geometry a little bit as we move into a little section of algebra. And this first lesson with some algebra is order of operations. Now, if you look at the top of page 245, you see 4 important steps. Now, obviously, order means that I have to do things in a certain order. And that is true about math, true about equations. And so we need to memorize these steps. Number 1, always, you're going to simplify or solve, do the math, inside the parentheses first. Then number 2 tells us that we're going to simplify, or I'll use the word solve, powers. Now that's exponents, okay? Powers means exponents. So if I had something that looks like this, remember 5 is my base, 2 is my exponent, this is a power, okay? So that's what number 2 is referring to. I would do that second before I did any other multiplication or division or of course, addition, subtraction. That is always last. So number 3 tells us that we're going to multiply and divide from left to right. And then lastly, we're going to add and subtract from left to right. Now, I'll work that example problem for us in just a second. But I first want you to look below those four instructions and see some examples of how it works. All right? You've already dealt with many different formulas. So here we see a formula, A equals pi r squared. Okay? A equals pi r squared. And we know that to be a special formula for the area of a circle. Now I want us to look at the math involved there according to this order of operation. Pi being 3.14, we know that. R standing for the radius. And then we see that the radius is squared. So we look at this and we see that there's no parentheses, but there is a power. So that's why this is very important for you to learn the order of operation. You must square the radius first, then multiply it times pi. That is an example of using the order of operation. Another simple formula that you know, the perimeter of a rectangle is P equals 2L plus 2W. 2L, this is going to come up in the very next lesson. I'm not sure why they didn't go ahead and talk about this, but that 2 beside the L and that 2 beside the W, remember, we've talked about it, it means a multiplication. It means 2 times L. L standing for length, W standing for width. So we're going to use our order of operation in that problem to know that we have to multiply first, both of those, before we add them together. So that is another example of order of operation. And then that last formula, and I'm not sure if you guys have used that formula or not. That is another area formula and of another shape, a little more involved. And notice the parentheses. So there's 2 things that's very important for you to understand on that one. The formula is A equals H, standing for height, times B sub 1 plus B sub 2. And that's 2 different bases is what it means. Okay? Base 1 plus base 2. But notice that's in parentheses. So we have to pay attention to that. According to the order of operations, remember, we need to do what? We got to add what's in parentheses first. So we're going to add base 1 and base 2 together before we multiply. Now the second thing I would like to point out to you for that one is that fraction bar. Okay? That fraction bar. So we have the height times B sub 1 plus B sub 2 over 2. This fraction bar, class, means division. All right, so what happens here is we're going to add these together, all right, first. Then we would multiply them times H. And then the last thing we would do is divide 2 into that number. So very important, that helps you to understand the order of operation. Now, we can work this one problem together here for order of operation. We have 6 plus 3 minus 2 in parentheses times 2 squared minus 5 divided by 5. So what we have here is a lot of different mathematical operations that are listed in one big long equation. So we're going to start with the order of operation that's been listed today, and we're going to look for parentheses. Do we have parentheses? Yes, we do. All right. So I can either rewrite the problem as I go, and that's what I'm going to do as we solve each step. So 3 minus 2 would be 1. All right, so now I've got 6 plus 1 times 2 squared minus 5 divided by 5. Next in my order of operation, it says to solve powers. Do I have powers? Yes, I do. I have one exponent here, so I need to solve it next. 2 squared. 2 squared means 2 times 2. That is 4, of course. So I'm going to rewrite my problem again. 6 plus 1 times 4 minus 5 and divided by 5. Okay? I left out my 1 there. Sorry about that. Okay? Now, my next step is going to be multiplication and division from left to right. So here's addition, but we have a multiplication here, and we have division here. Now, it would be real easy to want to try to go ahead and subtract and do something different, but you got to stick with this. So 1 times 4 is 4, okay? And then I can also do my 5 divided by 5. That's easy math. That is 1. Now, notice what's happening as we go down. We're simplifying. We're getting smaller and smaller, and we're going to get down to just obviously one answer here because we're just dealing with numbers. We're not getting deep into algebra with variables at this point. Okay? So now all that's left is addition and subtraction. So 6 plus 4 is 10, and 10 minus 1 is 9. So thankfully, on video, I didn't miss the problem. I got it right. And so that is the process. Now, I know a lot of you are going to try to look at this and you're going to try to do it in your head. You may be able to do it. But I caution you to be very careful because obviously one little mistake here and you're going to miss the problem. That's why I chose to take one step at a time, rewrite the equation as we went through each part of the order of operation. Now, the ones that you are going to be doing are not as involved as that example problem. So number 1, you're going to just follow the order of operation and answer all of those problems. Now remember, if you get stuck, go back and look at the example and the order and go through that. And parents, if you're watching too, you can help them with this. Obviously, it's not difficult there to get. Sometimes just have to go back through the steps and make sure we did everything in the proper order. All right. I'm going all the way through here. We got a couple more lessons to look at. So go ahead and flip over with me. And again, remember, it might be wise if you want to watch a portion, do the lesson, then you can come back and watch the next section so that you see how to do each lesson and each type of problem. So in lesson 137, we see, I already made mention to this, we talked about algebraic multiplication already. Okay, so we have a definition of algebra first. Okay, first time that we've seen that this school year. It says algebra is a continuation of arithmetic. It's a branch of mathematics that uses letters and other symbols to represent unknown numbers and applies arithmetical operations to them. Now, number 2 is very important. Thus far, and we even did it in this problem, what do we use to represent multiplication? We use this x here. Now, when you start dealing with algebra and variables, many times x is used as a variable. it is, in other words, it's a letter that represents a number that we don't know. It's an unknown. So to keep from confusion, when you delve into algebra, we don't use X as a multiplication symbol anymore. There are some others, and your book lists them probably there. One of them is a raised dot. So if we wanted to say 2 times 3, we could use this raised dot. It means multiplication, the same as that X did. 2 times 3 being 6. We also could use parentheses. These parentheses around these numbers means multiplication. 2 times 3 is 6. Now, we think about variables for a moment, and I think the easiest thing to do is to use one of the formulas that you know. Parameter equals 2L plus 2W. Now, when we first learned that formula, remember, many times we wrote it like this. How many remembers that? Hopefully you can see this part of the board. Can we see this, class? Down here? Okay. 2 times L plus 2 times W. And you know already, and this teaches what we're learning today, that 2L plus 2W is the same thing as 2 times L plus 2 times W. So what we're learning here is that a number beside a variable means multiplication. Okay? So very important for you to learn that. And your book gives you examples of P equals 4 times S, or P equals 4S being the same thing. Or A equals pi times R squared, or A equals pi R squared. Pi beside the R means multiplication. So in this lesson class, that is all that you will be dealing with there. So complete all of that lesson. Okay? And we're going to look now, maybe a little bit more difficult for you. We're going to look at one more lesson for this unit of material that we're sending home. So I'm going to take one short break here, and then I will come right back and... All right, lesson 138, solving equations. And so look at this with me carefully. And again, the good thing about this is, remember, as I always tell you, look back through these examples over and over as you're working the problems. That will help you to practice it. And the good news is, right after we finish this lesson, the next lesson you're going to do, the last one for this packet, is a review of what we're doing right now. So you're going to get lots of practice on solving equations. So first of all, they give you the definition. An equation is a mathematical sentence that uses the equal symbol to show that two expressions are equal. An algebraic equation contains an unknown number that is usually represented by a letter of the alphabet. Okay? So there's several rules that you need to know and understand. Now the first one that I want to go over with you is very important. This is an equation. It's equal. Okay? It is like a seesaw. All right? You've got to have the same exact amount on one side as the other to keep it equal and level. All right? Hopefully you've been on a seesaw before. If one person gets off, and that means it changes, then we no longer have an equal amount of weight and the seesaw shifts. I give you that example to help you to remember this fact. Whatever is done to one side of the equation must be done to the other. If not, it's no longer equal. If we had, again, that seesaw, if you took off 20 pounds from one side and you didn't from the other side, it would change. But if I took 20 pounds off of one side and 20 pounds off the other side, I still would be balanced and equal. Whatever you do to one side of the equation, you must do to the other side as well. And we're allowed, if you go ahead and look at the very, very bottom of this big example box, there are what's called axioms, and that's just a fancy word for rules or principles in math. We are told specifically for each type of operation that the same number can be added to both sides. We're allowed to do that. We're also told that the same number can be subtracted from either side. We're also told that the same number can be multiplied by each side. And then, of course, lastly, the same number can be divided into both sides, and it still be an equation. We're going to use those axioms as we work this lesson and solve equations. So let's just go ahead and do a couple here. We'll talk through it, and hopefully this will help you. The first one is n plus 8 equals 5 times 6. Now notice what we've learned, and be aware of this. What this is saying, guys, is that n plus 8 and 5 times 6 is the same thing. They are equal. But what we are doing in solving equations is trying to figure out and find out what the unknown number is. This n, this variable, stands for a number, and we need to find out what it is. So we're going to use some basic rules to be able to do that. The first thing always in solving an equation is to simplify, add or subtract on either side whatever we can, if there's just normal mathematics going on. So we look at this. Can we add n plus 8? No, we cannot. We don't know what n is. But we look on the other side. Can I multiply 5 times 6? And the answer, of course, is yes, I can. 5 times 6 is 30. So I always want to solve something like that first. And then I'm going to rewrite my equation. Okay? So here I am. N plus 8 equals 30. Now my next step, always in an equation, my goal is to get this variable all alone on a side by itself. So what I do is I look at this equation and I say, well, if I want n by itself, I need to get rid of the 8. But I can't just take it away, because remember, whatever I do to one side, I have to do to the other side. So what we like to do here, especially when it's plus and minus, think of it this way. What do I need to cancel out the 8 on this side? What can I do? All right? And I like to put it this way. I'm going to look at doing the opposite operation. What's going on here between n plus 8? It's addition. What's the opposite of addition? It's subtraction. So I can subtract 8, all right? And if I take a plus 8 and a minus 8, what happens? It cancels out. It's gone. And that's what I want to happen. I want it to be gone. But whatever I do to one side, I have to do to the other. So notice this. Plus 8 and a minus 8 cancels out, leaving me that n. 30 minus 8 is 22. Our answer, and this is correct, our answer then is n equals 22. Now, you always want to solve and check. How do I check? I take what the value of n is, I go back to my original equation, I plug it in, I substitute it, n for n, and then I solve and make sure I have an equality. So I take 22, and I will put it up here where the n was. 22 plus 8 is what? 30. 5 times 6 is 30. 30 equals 30, and we know that we've got it there, okay? So that is what we do there for the first one. And then look at the next one that they have for us. It is 6n equals 8 plus 4. So I'm going to go through the same steps, class. I'm going to look at both sides of the equation and see if there's something I can solve. Is there something I can simplify? Can I multiply? And remember what we learned in the last lesson, 6 beside the n means 6 times n. Can I multiply 6 times n? No, I cannot. Can I add 8 plus 4? Yes. So that's what I want to do next. 8 plus 4 is 12. I rewrite the equation. Now I have 6n equal to 12. All right? Now I look. Remember in the last problem, I want to get n all by itself. So I need to get rid of the numeral. And I'm going to do the opposite operation. 6 times n is multiplication. So I'm going to divide. What will get rid of the 6 down to just one n, or n? And that would be 6. So I'm going to divide 6 into both sides. 6 into 6 is 1. Okay? 6 into 12 is 2. Now, class, notice I wrote 1n. I did that on purpose so that you understand this fact. 6 into 6 is 1. It doesn't cancel it out like it did on the last problem. But when we have 1n, we never write it like this. 1n is just n. Final answer, n equals 2. Check it. Take 2, substitute it in for n. I'm going to use parentheses to show my multiplication. 6 times 2 is 12. 8 plus 4 is 12. 12 equals 12. And my equation is correct. One more kind here, very important for us to look at today. Okay? This one is a little more difficult to get the hang of. It is written like this. N over 6 equals to 16 minus 9. Again, what can I solve? The 16 minus 9. So I rewrite n over 6 equals 16 minus 9 is 7. Now, n over 6 is division. So I want to do the opposite of division. So that's easy. That's multiplication. But what do I multiply? Just as in all the other problems, I'm going to use the same number that I have. But I also, class, want you to think of this as a fraction. The fraction bar means division. So this looks like a fraction, and it is. So when I multiply by 6, I have to think of it this way. 6 over 1. Right? What happens in this case? We can cancel out the 6's. And what do we have? N over 1. And that doesn't change any value. That takes us all the way down, class, to simply n. I canceled out my 6's. N equals 7. Now, okay, we would go back all right, class, notice, hopefully you figured it out there. Very good teaching point here. What did we forget to do? As the main thing that I asked you over and over and over to do, I didn't do it. Made a mistake there, got in too big of a hurry. That's easy for the students to do. We multiplied this side by 6, but what did we not do? We didn't multiply the other side times 6. Very, very important. Got in a hurry to try to get the answer and forgot to do that. 7 times 6 is 42. There is our answer. Okay? So 16 minus 9 was 7. N over 6 equals 7. We multiplied both sides by 6. 6 over 1 cancels out to n. 7 times 6 is 42. Now, as I said a moment ago, these are very important and you have lots to practice here. Look back at your examples, and again, parents, if you were watching, I think you can help them with this. It's not that difficult, and you can go through these steps, just making sure you follow each one. Now, one last caution. I tell every class as I begin teaching equations. These are easy to figure out the answer in your head. The whole point of algebra at this level is learning the steps, learning the axioms, being able to solve the equations. To help you for your future in algebra, you need to work them properly. So I'm asking, as you turn in this work, students, if you do not have the steps where I can see that you solve the equation properly, it will be counted wrong. So don't just write down the answer. All right. For example, some of these, if you look at them, even the example number 1, n plus 8 equals 5 times 6. 5 times 6 is 30. And a lot of times in elementary, lower elementary, you just try to figure it out. Right? What times 8 gives me 30? Right? And then we can quickly realize that's 22. We write down the answer is 22. The answer's right, but you did not go through the steps or the process of solving an equation. Very important that you do. Okay, and as I said before, the last lesson you'll do for me for this unit of work is lesson 139. It is a review of the equations that we just went over. Now, students, please work hard at this. Do your very best. Parents, again, you're welcome to check it, let them correct it. I want them to get them right. I want them to learn the material and get decent grades so that we can go on forward. And I wish the best for each student and for each family, praying that you are healthy and safe during this time. And please contact me with any questions. Thank you. Have a great day.